Welcome to section 8.5. Today we're looking at proportions in similar triangles and three theorems that we can use if we know we have similar triangles. So the first one is called the side splitter theorem, and this is a really useful theorem. It says if a line is parallel to one side of a triangle and intersects the other two sides of the triangle, then it divides the sides proportionally. So the line we're referring to in this case is line BC. It's intersecting AD and AE, and it's parallel to this third side. So what that means is that any pieces that I have in triangle ABC are going to be proportional to the pieces in triangle ADE. So I can generalize this and make a proportion out of this, saying that AB compared to AD, the small triangle compared to the big triangle, is equal to AC over AE, small triangle compared to big triangle, which is equal to BC over DE, small triangle to big triangle. Now most of what we're going to do with this is algebra based. So in a question like this, we're going to try and find the value of x. So using the idea that we've got the parallel side, so knowing that these guys are parallel, we're going to say that the top pieces of the triangle are proportional to the entire side. So on the one side, I have a 14, and that represents the top triangle piece. And I'm going to divide it by the entire side. And this is where we have to be careful. The entire side is the 14 that we've already got, plus another x. It's not 14x, it's 14 plus x. On the other side, it's a little easier to do. We've got a 12. And we're going to compare that to the entire side, which is 18. It's generally a good idea, if we can, to reduce our numbers. I don't know about you, but I think 18 times 14 is not a very easy multiplication to do. And same thing with 12 times 14. So instead, I'm going to reduce that 12 and 18. I'm going to take a 6 out of there, and I'm going to make it 2 over 3. So 14 over 14 plus x equals 2 over 3. And from there, I can cross multiply and solve. So I'm going to do 14 times 3, that's 42. And on the other side, I'm going to do 2 times the quantity 14 plus x, so 28 plus 2x. From there, I can take 28 away from both sides, and I get 14. Dividing by 2, x is 7. So if I checked it, I'd have 14 divided by 21, which is 2 over 3. That's the same thing as 12 over 18. My ratio works. The next example is very similar to it, except we're trying to find this piece over here compared to the bases right there. So again, knowing that these guys are parallel, I'm going to set 5 over 5 plus y equal to 14 over 28. Now notice I did not have to add these up because this is the entire side for the small triangle and this is the entire side for the big triangle. Here I had to take the 5 because that's the small triangle's piece, and 5 plus y is everything. So again, reduce the 14 and 28 to 1 over 2. Cross multiply. I get 10 equals 5 plus y. Solving for y, I get 5. So again, using side splitter theorem, we set up proportions because we know that the triangles, the top one and the entire thing, are going to be similar. Next one we have is called parallel line theorem, and realistically we don't see triangles, but eventually there will be if these lines are going to extend out. It says if 3 or more parallel lines intersect 2 transversals, then they divide the transversals proportionally. L, M, and N are my parallel lines. These lines over here, the one on the left and the one on the right, are my transversals. So these parallel lines divide this up so that it creates a proportion. So in other words, A over B is equal to C over D. And here's the cool part about this. I can visually pick this out based on the diagram. A over B equals C over D. It's kind of setting it up for us. So as an example with this, you want to find the value of x. So again, these are parallel lines. These are my transversals. I have 3 transversals. What I can do is set up a proportion that's going to relate 15x, 26, and 30 all together. So the way to do this is I'm going to set this up as a proportion. Now I could do x over 30 equals 15 over 26 if I want. It's going to get me the same results. But I think it's easy to pick it out from the picture. So we're going to set up our proportion 15 over x equals 26 over 30. And again, reduce wherever you can. It makes things a little bit easier, although it's not going to be super duper easy on this one. I can take a 2 out, and I'm going to make that 13 out of 15. I'll cross multiply to solve. So 15 times 15 is going to give me 225 and 13x. Then to solve for x, I'm going to divide by 13. And there's nothing in 13 that goes into 225, so this is done. There's really nothing else I can do. What I want to caution you against, though, is turning that to a decimal. It is not a very nice decimal. And in general, we want to leave it as improper fraction. That's the preferred form. Now again, we could do the same thing if we were looking to find out the value of y. We could take 16.5 over 15 equals y over 26 and use the cross multiplication to solve it. And our last theorem is called the angle bisector theorem. And just like it says, you have to have an angle bisector to use this theorem. And what it basically says is if we have an angle bisector, that angle bisector will divide the triangle into proportional pieces. So in this triangle, if AD is the bisector of angle A, I can set up a proportion AC over CD equals AC over DB. And notice I'm using those corresponding pieces. Oop, that's a typo there. Let's fix that one. That should be AB. Ah, we're good. The corresponding pieces match up. So we've got an AC and an AB, and those are on either side of that bisected angle. Across from those bisected angles, we have those other pieces, CD and DB. So AC over CD equals AB over DB. You could also set up AC over AB equals CD over DB. There's a lot of different variations, but the main idea is to make sure your corresponding pieces match up. So in this problem, we know that angle A is being bisected. So using our theorem here, and sometimes again visually this picks itself out. We have 6 divided by 5 equals x divided by 8. And I've got that angle bisector theorem. That's going to help me out a lot. So 6 over 5 equals x over 8. And I'll cross multiply to solve. So I have 5x equals 48. X equals 48 over 5. This decimal, it's not so bad. So if you wanted to change that to a decimal, you could, and you can make that 9.6. Either way would be acceptable. And that's it for the notes, and again, we'll do some more practice with this in class.